This is video 27.3. We will be looking at the relativistic momentum and energy. The question: a proton has a rest mass of this value. We'd like to know what is the speed and momentum of a proton whose kinetic energy is equal to half its total energy. So it has rest mass energy and it has kinetic energy. And if the kinetic energy is half its total energy, we can find its speed and momentum. And we want to essentially repeat the same calculation for the case when the kinetic energy is equal to exactly half its rest energy. Step 1 will be to find the speed in case 1 where the kinetic energy is half of the total energy. So let's review relativistic momentum and energy. The total energy is given by this formula: gamma, or the relativistic factor, m naught, which is the rest mass, and c squared. This is assuming there's no potential like a gravitational or electric potential. The rest energy is Einstein's famous formula, mc squared. We have the 0 there just to remind us that it's the rest mass. And so the relativistic kinetic energy is just equal to the difference of the total energy and the rest energy, which is gamma minus 1 mc squared. So in case 1, we had the kinetic energy, which is on the left side, is equal to 1/2 of the total energy, which is on the right side. We can cancel out the mc squareds from both sides, giving us this relationship. Using this, we can solve for gamma, and gamma is just 2. Because 2 minus 1 is equal to 1/2 of 2, 1. And this is the formula for gamma. So we have to rearrange to solve for V. But if you recall from video 27.1, we already performed this calculation, so we don't have to repeat it. In that case, we started out with this relationship, the gamma is equal to delta T lab over delta T rest, and we solved it by algebraic manipulations for V. And V was given by this formula, and the quantity in parentheses inside the square root, notice, is the reciprocal of the value of gamma. So therefore, if gamma equals 2, it implies this value for V, where we have the reciprocal of the value of gamma, which is reciprocal of 2, it's 1/2. It gives us a value of square root of 3 over 2 times the speed of light. Which is 2.6 times 10 to the 8 meters per second. Now we can find the momentum in case 1 by using the relativistic equation for momentum, which is the same as the old one except with the gamma out front. So we have gamma mv. We know gamma is 2, we just found that, and we know V, which we also just found, and we were given the rest mass. So we have a value for the momentum. Now let's find the speed in case 2. We'll go through the same calculations just for practice. In this case, the kinetic energy, which is on the left side, gamma minus 1 mc squared, is equal to 1/2 of the rest energy, which is mc squared, without any gamma. Once again, we can cancel out the mc squareds, giving us a relationship just with gamma that we can solve to get gamma equals 3/2, or 1.5. Using the formula which was on the previous slide, we can solve for v, and we plug in the reciprocal of gamma inside the square root, inside the parentheses. There's 2/3. And we get a value of square root of 5/3c, which is just square root of 5 times 10 to the 8, because c is 3 times 10 to the 8 meters per second. Now let's find the momentum in case 2. The same formula applies. Gamma is now 3/2, and we just found v. This gives us our momentum. And that concludes video 27.3. Check out Physics X on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.